Hello, and welcome to this tutorial on using the write an equation strategy to solve problems. You'll recall from our previous modules that Poya's problem-solving process, the process we're using to solve every problem in this course, involves 4 steps: understanding, strategizing, solving, and looking back. We just discussed in our previous module the strategy of writing an equation to solve problems, and we looked at some of the math that's required to implement that strategy. Now we'll apply the strategy to a practice problem. The problem that we'll be examining today should be very familiar to you. If you've been reading about the credit crisis in the past 5 years, you'll know that there's a huge problem many consumers faced. That is, having a home that's underwater. When a home is underwater, the value of the loan on the home, that is, the amount the consumer owns on the home, is greater than the actual market value of the home. This means that if the consumer were to sell his home to somebody else, he would still owe the bank more money that he got back in the sale. Our friend Robert in this problem is in this situation. He has a home that has an outstanding loan of $500,000, but the home is only worth $400,000. So there's a difference of $100,000 between what the home is worth and the amount of the loan. Each month, Robert pays $2,000 against the loan, and each year the value of the home increases by $12,000. So is this a good or a bad thing for Robert? If we think about it for a moment, we can see that this is a good thing. Robert is successfully paying down the loan, so the value of the loan is decreasing, while the value of the home is increasing or appreciating. This means eventually the two are going to meet in the middle. When the value of the home is equal to the size of the outstanding loans, Robert wants to put the home on sale. He doesn't want this home anymore, but he also doesn't want to owe more money after he sells the house. So in how many months will Robert need to sell the home? Let's apply our problem-solving framework and break this down. You can see on this slide that the problem is written up above. So we're going to mine this problem statement to understand the problem. A good place to start is in our last sentence, because that usually tells us what we're looking for when we're addressing a word problem like this. So our question is, in how many months will Robert sell his home? We know that in the previous sentence, we can see that Robert will sell the home when the value is equal to the value of the loan. So our objective here is to determine when the home value is equal to the loan value in terms of months from now. Always make sure you know the units that you're asking to answer. So let's look at the information that we're given. What do we know? Remember that we want to set the value of the home equal to the value of the loan. So let's see if we have all the information we need to write these things down. First, do we know the home value? Well, we can see from our problem statement that the home is currently worth $400,000. We can also see that the value of the home is increasing by $12,000 every single year. So the value of the home as a function of time is given to us. We also know that the loan is $500,000 and that Robert is paying down the loan at a rate of $2,000 per month. So we also have the value of the loan as a function of time. Notice that the units of these two values are not the same. We know how the value of the home increases in terms of years, and we know how the value of the loan increases as a function of the number of months. So we need to relate the two. So we also want to write down for ourselves that we can relate these two. We know that there are 12 months in 1 year, or in algebraic terms, y is equal to 12m. 1 year is equal to 12 months. Now we strategize. We're solving for an unknown. That is an amount of time. We want to know how many months it's going to take Robert to have his home value and his loan value be the same. Whenever we think of solving an unknown, our first strategy thought should be writing an equation. Recall that in order to solve correctly by writing an equation, we need to know what our unknowns are, and we need to relate that to known information. We also need to have one equation for every unknown, and the equations cannot be equivalent. In this case, we have one unknown, the number of months that we'll need in order for the value of the home and the value of the loan to be the same. And we have one equation to solve for that one unknown, or we will when we write that equation, but we only need to write one. So our strategy here, since we have the value of the home and we have the value of the loan based on time, is to set the home value equal to the loan value and solve. Now we move on to our solve phase and actually write this equation that we've been talking about. Remember, we want to set the value of the home equal to the value of the loan. So let's look at how we'd write those two equations. We know the value of the home in our baseline case, in our first month, is equal to $400,000. We also know that it's increasing at a rate of $12,000 per year. So the value of the home at any given time is equal to $400,000 plus $12,000 times the number of years. So after 1 year, we'll have $400,000 plus $12,000. After 2 years, $400,000 plus $24,000, etc. The value of the loan, on the other hand, we remember, is decreasing. So we take our initial value of the loan, $500,000, and subtract $2,000, the value of the loan payment per month, times the number of months. So we could go and set these two equal to each other, but we have to remember that one is written in terms of years and one is written in terms of months. So we actually have two different variables here. But remember, we know how to relate these relatively easily because we know that there are 12 months in a single year. So we can, because we want to solve for months, let's convert the value of the home, which is changing as a function of years, into an equation that changes as a function of months. And the simple way to do that is simply to divide the value of the change per year by 12, the number of months in a year, to get the change per month. So if we do that, we have 400,000 as a base case, plus 12,000 divided by 12, or 400,000 plus $1,000 change per month. Gives us the value of the home as a function of months. So now we solve. We set both sides of our equation equal to each other. So our value of the home here is on the left-hand side of the equation, and the value of the loan is on the right-hand side of the equation. And we want to solve for the value of m that is going to make these two equivalent. So what is our first step anytime we balance an equation? The first step that we should think of each time we balance an equation is doing the same thing to each side. We want to isolate our variables to solve for them by doing the same operations to each side. This is because we want to isolate our variable. So in this case, we want to get m on one side of the equation. And the simple way to do that is to collect all of the terms with no variable attached, just the raw numbers, on, in this case, the right-hand side of the equation, and all of our m variables with the coefficients in dollars attached on the left-hand side of the equation. So to do that, we'll subtract $400,000 from each side of the equation. This cancels the full value, $400,000, from the left side and turns the value on the right side into $100,000. We're also going to add $2,000 to cancel out the right side of the equation, or rather $2,000 times m, and cancel on the right side, and then add 2,000 times m on the left side, which gives us $3,000 times m on the left side and $100,000 on the right side. Again, we want to take whatever steps possible to isolate m. In order to do that, because we have 3,000 times m on the left side of the equation, we need to divide each side of the equation by $3,000. This gives us m is equal to 33.33. So the number of months Robert will need is 33.33 months. We've obtained the value of m, so we've solved our equation. And now it's time to look back. The first thing we do every time we look back is check. Did we answer the question asked? Yes, in this case we did. We gave the time for the loan and the home value to be equal to each other in months. We also want to check our equation. Remember, when you're checking the solution to an equation, you can simply plug the value of the equation back into the original equation and see if the equation is satisfied. That is, each equation has a right and a left-hand side that are equal to each other. If we were to do this for this problem, we would see that our solution is correct. But it's something, at least until you've mastered writing equations, or anytime you're taking an exam or doing something for work, that you should always do. Always double check. And finally, interpret. What does our value of 33.33 months mean? It means a few different things. First, it means that the 33 1/3 months are required for Robert to have his loan and his home value be the same. It also means that after 34 months, Robert will have paid off everything that he needs to pay off. He won't have paid it off at 33, but he will have paid it off at 34. In sum, we were able to see how we could apply the right and equation strategy of problem solving using Polya's problem-solving process